Imagine waking up on Mars. No suit, no helmet, a pale blue horizon. Small lakes shimmering in ancient craters. You open the window. You take a breath. Now imagine explaining to your kid how we got here. We didn't build this world. We bombed it into existence. Could 10,000 nuclear weapons actually give your children a second home? And why can't we fix Earth? Let's face it. Step onto Mars today without a suit, you'd be dead in 90 seconds. Not from the cold, not from radiation, from the pressure. Mars' atmospheric pressure is 0.6% of Earth's. Standing there is like floating in open space. Nitrogen in your blood instantly forms deadly bubbles. Your saliva boils right on your tongue. Ouch. Average temperature, -81 degrees Fahrenheit, colder than dry ice, every single day, everywhere. Well, humanity has turned impossible ideas into history before. In 1969, America put men on the moon using computers weaker than the phone in your pocket. Back then, that sounded insane too. So when Elon Musk posted 2 words on Twitter, "Nuke Mars," the world laughed. It sounded reckless, maybe even crazy. But then, physicists actually ran the numbers. And the basic idea is not complete nonsense. Mars has something powerful locked at its poles. Billions of tons of dry ice, frozen carbon dioxide. Heat it fast enough and it does not melt like regular ice. It jumps straight from solid into gas. That extra carbon dioxide could thicken the atmosphere and trap more heat. That is the part that makes people pause. But here is where the dream runs into a brick wall. Scientists counted the major carbon dioxide sources on Mars: the frozen poles, the soil, the minerals buried in the ground. Even in the best case, releasing all of it would only raise Mars's air pressure to about 7% of Earth's. 7%. That means you still could not breathe. You would still need a pressure suit. The nukes might start the process, but they only get Mars a tiny part of the way there. And then comes the bigger problem. Mars has no global magnetic field. Earth's magnetic field helps protect our atmosphere from the solar wind. Mars does not have that shield. So even if we added more atmosphere, the sun would keep stripping it away, molecule by molecule. It is like trying to fill a bathtub while the drain is still wide open. But what if we ignore the limits and forcefully push the button anyway? To even get that 7%, we strictly have to ignite the sky. To put it in perspective, let's look at our tool. The biggest nuclear bomb ever tested was the Soviet Tsar Bomba in 1961. It exploded with 50 megatons of force, over 3,000 times stronger than Hiroshima. The massive shockwave circled Earth 3 times. Windows shattered 560 miles away. Now picture using not one, but thousands of bombs like that on Mars. Suddenly, Nuke Mars stops sounding simple. Let's track a single detonation. The live warhead reaches 30 miles above the Martian North Pole. 1 millisecond later, a blinding sphere of plasma forms. Core temperature hits 100 million degrees, 7 times hotter than the sun. For 1 terrified millisecond, Mars has a second star. 1 second later, the shock wave expands at 5 times the speed of sound. On Earth, this violently ruptures eardrums 100 miles away. On Mars, absolute silence. The most powerful explosion in human history, and you'd barely hear a whisper. Mars is so entirely empty, the bomb doesn't even scream. 10 seconds later, the searing thermal pulse hits the ice cap. Dry ice sublimes. Tens of billions of tons of carbon dioxide rapidly erupt into the sky. Think of violently uncorking a carbonated bottle the size of Texas. The cork was a live nuclear weapon. 1 minute later, the dark mushroom cloud rises 40 miles. From orbit, it looks exactly like a beautiful sunrise. This isn't destruction. This is construction. The most violent construction project in history. And in 24 hours, we do it again. Now, logistics get deeply complicated. SpaceX's Starship carries roughly 220,000 pounds to low orbit. That gives us exactly 3 bombs per launch. You need thousands of consecutive launches, each securely carrying thermonuclear warheads directly through Earth's atmosphere. What if a fueled rocket explodes on the pad? We wipe off the face of the Earth a massive chunk of Florida. Bye-bye, launch complex. The U.S. spent over $8 trillion on Middle East wars, leaving us with a bunch of bones and heavy debt. This planetary terraforming project easily costs trillions too. But you're killing 2 birds with 1 stone, eliminating ancient nuclear stockpiles while forcefully securing a brand new planet. I know what you're thinking. What if we tragically miss? The live bombs absolutely must detonate high in the sky. If even one hits the dirt, we furiously push the panic button. Deadly radioactive contamination blasts directly into the soil, into the precious water ice we're desperately trying to liberate. Any future colony becomes entirely uninhabitable for 10,000 years. 1 navigation error. Humans are incredibly good at almost getting things right, when the stakes are planetary and almost would completely ring bad. There's a vastly worse scenario. The powerful blasts kick up millions of tons of fine red dust, completely blocking what little sunlight Mars already gets, triggering a global nuclear winter. Instead of a warm greenhouse, we blindly built a giant radioactive freezer, setting the massive project back by a full century because of dust. The choking dust that wiped out the dinosaurs could violently end our master plan. Ugh. But let's blindly assume the bombs entirely do their job. Global temperature slowly climbs, just a few crucial degrees. 10 years later, frozen permafrost near the equator heavily melts. Liquid water finally appears on the harsh surface for the very first time in 3 billion years. Delicate films of salty brine are barely a single millimeter deep. Scientists eagerly watching the live feed from orbit don't say a word. Some just lean back and openly cry. You probably would too. 25 years later, we safely send in the living reinforcements, genetically engineered extremophile algae, built specifically to survive intense ultraviolet radiation, punishing low pressure, crushing cold. Their one evolutionary job is to endlessly eat carbon dioxide and breathe out pure oxygen. We're running the exact same biological play blue-green algae made on Earth 2.7 billion years ago. Most fragile capsules instantly crash and die, but some highly resilient capsules naturally survive. They are the absolute only ones that matter. We're actively engineering life to engineer the planet for us. Your grandfather proudly built concrete highways. Your generation? You literally built a breathing biosphere. Pretty spiffy, yeah. To fix that terrifying missing magnetic field, NASA's Jim Green proposed an artificial magnetic shield, floating out in deep space precisely between Mars and the Sun, actively bending solar wind completely around Mars. The entire red planet securely tucked inside a massive invisible bubble, arriving in the nick of time. A bunch of your tax dollars actually paid for that wild idea. Good news is, they might genuinely be completely worth it. 500 years after the very first bomb, atmospheric pressure confidently hits 18% of Earth's. Average global temperature steadily climbs to 14 degrees Fahrenheit. Cold, but beautifully survivable. Not so radically different from a freezing February morning in Denver. The first outdoor markets open in the deep Hellas Basin, where air pressure is naturally higher than almost anywhere else on Mars. People sell modified root vegetables grown in red Martian soil. Kids chase a soccer ball through the thin, cold air. No heavy pressure suits, no bulky glass helmets. They may never know the names of the people who started this dream, but they know one thing: this red world is finally home. And that brings us right back to where we started. Before we pop the champagne, there is one final catch. Scientists have found strong evidence that liquid water may still exist deep beneath the Martian surface. Where there's liquid water on Earth, there is active life, without a single biological exception. If something microscopic is currently alive under the dark ice on Mars, biologically dormant, 3 billion years old, then every single nuclear bomb we blindly drop is a massive extinction event we deliberately chose. We'd aggressively wipe out the only other origin of life in our entire solar system, and we'd proudly call it progress. We've repeatedly made that brutal trade before, right here on Earth, with innocent people already peacefully living there. Ask yourself how that dark chapter realistically reads in modern history books. Here is the financial math nobody wants to put on the table. Fully terraforming Mars would conservatively cost tens of trillions of dollars, and that money would be spread painfully across centuries. Stabilizing Earth's rapidly worsening climate, roughly $4 trillion a year for 30 years. That is in the same massive financial ballpark. But here is the difference. We could start fixing Earth tomorrow morning. No experimental heavy rockets required. So is Mars really our backup plan? Or is it just the most expensive way to avoid cleaning up our own house? 10,000 nuclear bombs to build a colder, harsher world. Or 30 years of hard choices to protect the paradise we already have. Both choices come down to the same thing. Not bigger rockets, not smarter machines. Self-control. Can we sacrifice what feels easy today for a future we may never personally see? That may be the real test. Not whether we can reach Mars, but whether we deserve to. If you want more wild science pushed to the edge, hit like and subscribe. The universe has laws, but we're here to push them to the breaking point. I'm Rabo, and the lab is always open. Catch you on the next one.